Good morning, all you wonderful people who make the world go round. We're going to go ahead and start off with rational exponents today. We'll skip that. So simplify the following. Before we get into rational exponents, we have to review how to work with radicals. So if you remember, this means the square root of. So let me just start off with an example. So let's go with 36. I'm going to write it right here. So square root of 36. So if I asked you, what is the square root of 36? I'm hoping that you're going to say 6. Now this is something that you might have covered in Algebra 1 or possibly plenty of times before that, So I'm kind of assuming that you guys might already know this. So the square root is basically what two numbers can I multiply to get the number under the radical. So in this case it'd be 6 times 6. 6 times 6 is 36, but if we're reading it from this side, starting with the radicand, that means the number underneath the radical. So 36, again, is what two numbers multiplied together. So that would be 6. So square root. Now, 36 is a square number, just like these are square numbers, 4, 9, 16, and 25. So 4 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, and lastly 5 times 5 is 25. So you're taking two numbers, the same number, and multiplying them together to get a square number. In this case, they call it a square factor. So we got to break some of these into factors. So I need two numbers that can multiply into 28. Now, you could factor this entirely, and by factoring entirely, I mean something like this. So let's take 28. So 28, and I'm going to break it down into two numbers. I have to ask myself, what two numbers can I turn 28 into? All right, so let's see, maybe 7 times 4. Now in this case here, we do have a square factor, because both of these numbers multiply. 7 times 4 equals 28. And a factor is a number that you use to multiply to get another number. So 7 and 4 are both factors because you use them to multiply to get 28. Now to write it out the long way out, you would do something like this. 4 times 7. And these two numbers are both under the radical. And you would split them apart. So root 4 times root 7. Because I'm already taking the square root of both 4 and 7. So I'm going to kind of split it at the multiplication. So 4 times 7, like this. But again, they're both underneath the radical. Now, I do have a little bit of a I can do the next step because I do know the square root of 4, right? Square root of 4 is going to be 2 because 4 is a square number. Now, I would put a little dot right here so it looked like this, but I'm going to kind of write it lightly because we don't really need it in the next part. So there we go. We simplified the square root of 28. Now, we're not looking for an exact value, so we're not going to be using our calculators for this one like you would have for the bell work. So let's go ahead and try another one. Now for 50, I need two numbers that multiply to 50. And you might be thinking something like 5 times 10, which is usually what most people would think of first. 5 times 10 is 50. Now that doesn't quite work out because neither 5 nor 10 are square numbers. We want to look for square numbers to use as factors. So I'm going to use 2 and 25 because I know that 25 is a square number. So 2 times 25. Now I can find the square root of 25. So again, I'm going to split them up. And to make this a little bit easier, remember that you don't have to really always multiply numbers in the same direction. So what I mean is that the commutative property says that you can multiply 2 times 25 or 5 times 25. All right. So again, commutative property, 2 times 25, 25 times 2, going to be the same thing. Order doesn't matter. We can multiply whichever number, and we're still going to get the same amount. So I'm going to switch the side, so we get 25 times 2. Now again, we can take the square root of 25. I hate to have to skip some steps, but I'm going to kind of cut out this middle step here, where I would take square root 25 and square root 2, otherwise I'd run out of room. So square root of 25 is 5, so it comes out of the radical. It has less power. Well, the numbers in the radical can oftentimes look bigger, because a lot of people might say something like, well, there was a 25, but why did we take out 5? Well, that's kind of what we're going to get into today. So let's go ahead and try the next one. So let's go with 45. Now we need to think of some numbers that we can multiply to get 45. So one number might be something like 3 times 15. Okay, now 3 times 15 are both factors that will multiply together to make 45, but neither of them are square numbers. We want numbers that are square numbers. So we need a different set of factors. So we got to think here, what are 2 other numbers we can multiply besides 3 and 15? Well, maybe 9 times 5? Now that works out because 9 is a square number. Now I'm going to put my square number first. 9 times 5. Like that. So 9 is my square number because we know that 9 is 3 times 3. So in this case here, I am going to break them apart so that they are each in a radical. So again, this equal means that these two things are the same thing. 9 times 5, 9 times 5. And they all have the square root symbol, the radical. But we can take the square root of 9. So that would be 3. Now, 3 times the square root of 5, and we don't really need that dot, which normally when you write this, you don't really have the dot. You just put them together. Quick explanation for that. It's kind of like if I were to multiply 9 times a. 9 times a, we would just write that algebraically as 9a. So same thing. 3 times square root of 5, or we don't really need to say the word times. Well, we say the word times, but we don't need to write out the dot. And last one, 98. So I need 2 numbers that will multiply to 98. So you might think of like 2 times 49. Oh, well, what do you know? I got a square number on my first guess. That's probably the number we're looking for. 2 times 49, so I'm going to put 49 first. Sometimes you just get lucky and you get the square number you're looking for first. Because 98 does have a lot of numbers that you can multiply to get 98. But I want the biggest square numbers that I can. And again, square numbers are 2 numbers multiplied by itself to get another number. So 49 is 7 times 7. So I'm going to take the 49 out, but when it comes out, it turns into 7. So 7 root 2. Now I did kind of skip a little bit on the first one in the interest of time, but I'm going to show you really quickly that this is the same thing as that. So again, when you use the equal signs, it's the same thing, but sometimes you often change how it looks. When you change something a little too much, sometimes people don't really think that it's the same thing. So I'm going to go ahead and take the square root of 2, I'm sorry, the square root of 98. So in this case, I get 9.899, and I'm just going to go to 3 decimal places. That's common. 9.899 is this number. So I took the square root of 98. Now I'm going to go find the value of this one, and it should be the same thing. It should be 9.899. So clear that off, and I'm going to go and take the square root of 2. Now I have to do this because my calculator is not really the best, and sometimes it doesn't follow the order of operations the way you want it to. So I'm going to play it safe, and I'm going to take the square root of 2, which is 1.41. Okay, we're not done yet. I need to multiply this number by 7. And we do get 9.899. So these numbers have the same value. So even though they look different, they mean the same thing. Okay, now let's go ahead and I can let you get some of these, and maybe we'll go over them. So if you need to, go ahead and pause the video, try some of these on your own, and I'll give you the answers in a few seconds. Okay, I hope you stopped and tried to solve this on your own. I know it's kind of like Dora the Explorer or something when people tell you to try something and you just sort of stand there and look at them and wait for them to say something. But again, I highly encourage you to try these on your own. Let's go ahead and go over the answers. So this first one here, I need two numbers that multiply to get 48. And I think most people might think of something like 8 times 6, but again, we're looking for square numbers, which in this case is 16 and 3, so 16 times 3. And we're looking for the square root. That's supposed to be a times. 16 times 3, and we know that 16 is a square number, so 4 root 3. Now I need numbers that multiply to 300, and again, there are a lot of numbers that you can multiply to 300. One thing you could do, if you remember, is to make a factor diagram, which is like, it would be something like this: 1 times 300, 2, and I'm going to raise my numbers as little amount as I can each time, and think, okay, so 1 times 300, 2 times what gives me 300, so that'd be 150, 3 times 100, and there's a lot more too. I could divide it by 4, you know, I could multiply a number by 5 to get 300. I could multiply a number by 6 to get 300, but we already arrived at our biggest square number that we could get, and that is 100. Since 100 is a square number, because it's 10 times 10, 10 times 10 is going to be our outside number, and 3. Again, I'm trying to go through this to give you guys the answer, but hopefully you tried this out and you got 10 root 3. For 150, even though you might think of something like 50 times 3, well, neither of those are square numbers. We want square numbers, so we're going to have to keep trying again, and I got 6 times 25. 6 times 25. Now 25 is a square number. The square root of 25 is 5 root 6. Now I can't take the square root of 6, so it stays in the radical. It stays underneath this bracket. And 80, again, I would imagine most people would say 10 times 8 or something like that. Or you can also make a factor tree like we did for the first one, if you're not sure, and look for the numbers that either repeat themselves or are square numbers. So 8 times 10 doesn't quite work out, but 16 times 5 does work out. So I can take the square root of 16, and that would be 4. And I'm going to go ahead and take the radical, which is 5, because I cannot take the square root of 5. There are no two numbers that I can multiply to get 5. So in this case here, we have 4 times the square root of 5. And there we go. So that's the first part. I'm going to pause it here, and I'll put another video out for the next part.